LLMs keep getting better, and LLM is starting to be the wrong term because they now have they have vision too, and they do all kinds of other things. But many of them have a very fatal flaw, and that is that they don't know about me personally, and I'm very important. So the question is, how do we get AI models to know about our data and avoid hallucinating? The question here is not about all of the models being right. The question is about control. How do I, as a developer, make control the model so that whatever my version of truth is expressed through the model and is expressed to my users? We've kind of talked about this already, but for retrieval, instead of going straight from user enters the command to system generates text, you put these things in the middle. Step two, it searches for data that is relevant to the command or the question. So we haven't touched the generative AI model yet. It might go out to process the information in some kind of tool, and then it copies the relevant info into the prompt, and then it generates the text. So this is where we actually start involving the generative AI at all. It would look something like this. I literally give it my bio, and then lo and behold, it can talk about me. Why? Because I just gave it the information. It literally is, it's like an open book test. You can do search a lot of different ways. But when we're talking about large language models, usually the way that we're doing it is something called vector search. And with vector search, we use this thing called embeddings. And these are terms that you might have heard out in the wilds of the AI internet. So I want to talk about a little bit what that means. You'll remember that in the first class, we talked about language models as a map, like a many dimensional map. And that if this map was of a city, buildings that were close to each other would be words that are similar to each other or things that are similar to each other, and buildings that are far from each other would be words that are different from each other. Um, and we use this map in order to generate text. We can then also use this map to come and put things that don't exist on the map yet in order to search for them. So for instance, here's our language model. And let's say that we have two separate, let's say that we have two documents, and we come and we place these documents on this map. One of them is Jeremy is an AI educator, and one is AI is more exciting than blockchain. If the user comes in and says, who is Jeremy? We're going to look for which is closer to this question, who is Jeremy? And this document, Jeremy is an AI educator, is more similar semantically to the question. And so we would then pull that document. This works in a lot of cases, and then also doesn't work in other cases. It works in a lot of cases to understand natural language text, but it fails in a lot of cases too, right? So if I come in and I say, if I have a database of jokes and I ask what is the best joke, it's going to look for jokes in there that have words that are similar to best and words that are similar to great. As opposed, perhaps the most high quality joke in there might be, why did the chicken cross the road? Because my query has nothing about the word chicken or roads in it, I'm not going to pull the right document in that case. So that's when you go back and you use your LLM chains, like we talked about at the beginning, to try and improve that. You use the LLM, you might ask, what's the best joke? And then you might say to the LLM, before you pull a document, write a joke that might answer this question, and then use that answer to map to the documents, et cetera, et cetera. The important part of that is that there's ways to get around this, but this doesn't always work exactly the way that you'd want. When we're talking about vector databases and we're talking about embeddings, this is what we're talking about. You're taking the language model as your original map, taking your documents and placing them on that map, and then looking for which of the documents is closer to the user query. So just to break this down one other way, I think we understand this part. User enters a query. Search system attempts to match query with relevant information. Search system copies information into the prompt, and then LLM generates the response. So the LLM doesn't change. you have your repository of true information, whatever that means to you. And then the search system is handing off between this repository and the LLM.